Hello. Today we will demonstrate the solution for continuous glucose monitoring, which is augmented with FitBit heart rate monitoring, and we will demonstrate how those two devices can be used together. Before we go to the details of the demo, I would like to spend a couple minutes just to explain the reason behind of this demo. Basically, based on the um, importance of the early diagnostics of potential disorders and diseases that might come for people in the risk groups, such as elderly people, people with some chronic conditions, um, young people with chronic diseases like diabetes, um, some disorders related to cardiovascular problems, as well as the people with sleep disorders and some others risk groups. As we probably know from our experience and dealing with family members who at the aged all the time, they might feel great, but at the same time, the symptoms might be manifested itself later. And by that time, when the person starts to be consciously aware about the symptoms, it might be, if not too late, but at least lead for the longer recovery time and require expensive and long intervention with a specialist and the healthcare providers. So that tell us that how wearable devices might be important. Also, working with the partners, we realized that some of those devices, such as FitBit and Google Assistants, recently demonstrate quite unique functionality that help people early diagnose that something happening with their heart, and they've been able to approach the medical providers, the doctors, with the complaints that they might feel some problem with the heart, with the fitness, and with other aspect of their life. So that give us a strong motivation that Fitbit might be one of those devices that can provide very important information, such as heart rate, how many calories being burned, and other aspect of the human behavior and human activity. Specifically, we've been exploring the use cases, working with our customers and partners, use cases related risk group, those people who might experience cardiac arrest or some cardiovascular problem during the nighttime, diabetic people who might be suffering a dramatic drop in the glucose level during nighttime, people with epilepsy or obstructive sleep apnea, all those people in the risk groups, and they really need a device that will help them to monitor the state of health. Also, they often asking about non-expensive devices that may let them or their family members get an alarm in case if something dangerous might happen with the level of glucose, with their heart, with their breathing activity. To accommodate those requests, we come up with general patterns, how we can leverage several wearable devices. One of them is continuous glucose monitoring that provide information about the glucose level of the patient. And the second device is a Fitbit heart rate sensor, which is basically part of the Fitbit. And we developed a solution that acquire the data from those two devices. It store this data in a Google Cloud, provide the primary data processing. Then the data get moved to the Google Warehouse BigQuery, and the machine learning pipeline get kicked off to create the models from the time series. And for this particular pattern, we use two time series. One is a time series of glucose level measured by CGM, and another time series is heart rate provided by FitBit. Those models used to first predict potential variations in glucose level and the heart rate, and also, which is probably more important, to detect various abnormal behavior, like anomaly detections. And in case if the both devices detect some striking anomalies, then they activate the pipeline that provides emergency call to the caregiver or the family member. Example of the use case where those two devices might be used would be situation when the person might be falling to glycemic coma. In that situation, we typically reported that glucose level goes down, and at the same time, the heart rate dramatically increase. Those two trends definitely will be manifested as anomalies, and if the pipeline detect those two anomalies over the same period of time, then it has higher probability that it's not will caused by the way the customer wear those devices, and there is no failure on device, but most likely that the cause of those two anomalies is some health problems which need to be immediately addressed by the caregivers. This solution has three main parts. The first part is data acquisition, which is basically scheduled cloud function that pull in the data from both devices every 15 minutes. The data stored in the pub subtopics, and then data flow service is used to move the data in real time from pub subtopics to the BigQuery warehouse. The second portion of the solution is actually the data processing pipe, which is scheduled queries and data flow jobs that do the data transformations and kick off the training of the various machine learning models. And the last part is action pillar, which is basically responsible to initiate emergency call if the certain anomalies get detected. Now I'm going to go through some details of the solution, and then at the end I will demonstrate the actual components in the Google Cloud Console. As I mentioned, the first piece of the solution is a glucose monitoring path, which is basically first collect the glucose values for continuous glucose monitoring. Also, in Google Warehouse, we keep track of the subject, basically to the subject ID. We store in the display time, which is tell us what time the measure was done. Also, we find it helpful to store some information related to subject behavior, such as eating behavior, like how much protein, carb, and fat was consumed by the person and at what time, if the person might use the insulin to mitigate the fluctuation of the glucose. We also store this information. At the same time, we store some weather-related information, which might be important for elderly people who might be weather dependent. Also, we store information about the activity. So as you can see, the activity is stored as a flag, which is 0 means no activity, and then the number roughly represent the amount of calories that consumed. By the way, this information also, number of calories can be consumed, can be acquired from the devices like a Fitbit and various fitness trackers. Then on the BigQuery, on the Google Cloud, we developed the models, forecast models that leverage all of those data to do the predictions. Google Cloud provides various ways to build the models for multi-time series data. We use the Vertex AI that allow us to specify different time series, as I mentioned, glucose values, consumption of the protein, carb, fat, activity. This is an examples of different time series that used by the algorithm to do the predictions. And the prediction will be either glucose variations or the insulin amount that might need to be recommended for the person to inject to mitigate the fluctuation of the glucose level. For the single time series, we also leverage the BigQuery machine learning methods that allow us quickly to create the model for the single time series, such as glucose, and then this model allow us to do the prediction for the if the glucose is going to rise or fall, and also we use a Vertex AI model to do the prediction for the insulin consumption. So in case the insulin goes dramatically high, the model predict the amount of the insulin that a person might want to inject. This graph just represent the data, predicted insulin units that need to be administered based on the fluctuation of the glucose level. The second portion of the solution is the FitBit data. As you know, FitBit provides a lot of information about human activity, like how much calories was consumed, heart rate, and specifically for this demo, we use the heart rate sensors. There's a few steps before using the solution. You need to register the application with the FitBit, generate your OAuth client ID that will be used by the pipeline to pull the data from your FitBit device. This slide demonstrates the time series data that can be collected. You can collect the data over day and nights, which is also important to train the model because of obvious daily and nightly variations of the heart rate is important. Then the pipeline basically has a scheduler that pull the data, that call the cloud function to pull the data from the devices, from the FitBit or the continuous glucose monitor every 15 minutes. And then the data get collected and stored in the pub subtopics. Then it kicked off the data flow, which is pull the data from the pub subtopics and do some simple transformation and then ingest the data in the BigQuery tables. Then, as I said, we leverage various scripts to create different type of models. Those models can take heart rate data and then either do the prediction for the heart rate data variation or detect the anomalies. In case if, for example, average heart rate is 60 to 70, then over time it might be rise to 400s. Then there is another cloud function that orchestrates the alarm call. To do the outbound call, we used a partner solution in conjunction with a Google service such as Dialog Flow. For the partner solution, we can leverage a Plivo library or Twilio library that allow to quickly build outbound call pipeline and initiate outbound call in case of anomaly detection was presented. And the final component of the solution is the Dialog Flow that can be activated when there is anomaly detected, which allow caregiver to get the phone call with notification that something goes wrong with the patient, and then or family member, and then get some more details on what's been detected by devices. Now I'm going to switch and go quickly through the component of the architecture. As I mentioned, right now in the solution, there is two schedulers, one scheduled for Dexcom device, continuous glucose monitor, another scheduled for FitBit. This is in the real time, as you can see, we pull in the data for those cloud functions every 15 minutes for both functions. And the source code is very simple. Basically, we use Dexcom public API to pull the data from a simulated device, and then after some transformation, the data get injected in the PubSub. And the similar function developed for the FitBit. Again, we pull data every 15 minutes, and the function use the token to access your personal devices. In that case, I use my personal devices to pull the data and store it in the database. As you can see, those topics demonstrate the request per seconds, how the data being injected in the PubSub. As you can see, so there is some period of time when the device is turned off, so there is obviously no data, but then there is a time when the device is turned on. For the PubSub, from the PubSub, the data moved to the BigQuery. Again, we have Dialog Flow that successfully provides us information about how successful the process, and we can explore both pipelines to see how the data get pulled from PubSub and injected in BigQuery. As soon as the data in the BigQuery, it actually kicked off other pipelines that can be created with a data flow or with the scheduled queries. The scheduled query mechanism allow you to do the ELT. Basically, you can load your data and do the transformation within the warehouse. Also, BigQML functionality allows you to create the models within the BigQuery using the SQL. So that's an example of the data that we inject in the warehouse. As you can see, the blue line demonstrates the glucose level. The red big one demonstrates the activity and an amount of the calories, how much calories was burned. And on the bottom, you can see the predicted insulin that algorithm suggests to be administered based on the information. As I mentioned, the way how to build the models, there's the two ways. One is for single time series, like if we'd like to predict glucose level, we use ARIMA Plus model. But if we would like to leverage multiple time series, like for example, temperature, consumption of the protein, carb, fat, then we leverage Vertex AI, Vertex API to build model and do the predictions. Okay, now it's a time to talk about the FitBit part. For the FitBit, same thing. So we basically collect the data about heart rate, and those data present the average heart rate of the period of like 1 minute, and then we build the ARIMA Plus models that allow us to do the predictions. On this graph, you actually can see the real data and then expected prediction. But we artificially introduce some anomalies. So we introduce the heart rate about 300, which is anomaly, and this anomaly can be detected with our model. So as I mentioned, we have a script that create a forecast model, and based on the forecast model, forecasted values should be within something like within the 50 contraction during the minute. But because we introduce anomalies like a very high rate, and we simulate the situation when the person might be falling to glycemic coma, we would like to check if our pipeline will be able to detect anomalies. And as you can see on this part, this query, when it's run, it's actually detect all of those occurrences of the high rate, and basically it was able to detect all these anomalies, which trigger the alarming call. And in this situation, I can stimulate this alarming call because obviously
You have very high heart rate and low glucose level. Please check the dialog phone number to explore options.
As you can see, I just simulate the situation when the anomalous value in the heart rate trigger the outbound call that I got to my personal phone number. And finally, if I would like to get more details, this pipeline connected to Dialog Flow, which is through the Dialog Flow Home Gateway integration, allow me to get more information on what's going on. Let's see how it works.
You're monitoring your father's heart rate and glucose level and detecting some strange signals. Could you please check? We are monitoring your father's heart rate and glucose level and detecting some strange signals. He has very low glucose level. Please call doctor.
So this simple demo illustrate how the pipeline can be used and how we can leverage multiple wearable devices to develop comprehensive solution. Thank you.